outside world. Okay, just like we have our pet world, okay, which is inside our home, and the official name which is outside our home, right? Like Chunnu Munnu, we call it in our Kutti and all those things. We call it when we are at home, okay. But official name, you can have it outside the world as standard names like Ravi, then Renuka, and so on and so forth, right?
So
We
in the
call it
same way,
when we are at here, using this service concept, what we are going to do is we are going to expose this to the outside world. So I'm going to expose it using the ODT. So my service name is also I have given as Nginx app. Okay. Now I have given this. So I'm going to go ahead and I'm going to check that where exactly it is exposed. Okay. Don't worry about the commands. We are going to work on the commands also. But quickly, let me just show it to you. Okay, so let me describe it. So here, as you can see, my service is exposed on the port number 32588. Okay, 32588, right? So now I'm going to go ahead and I'm going to open that Nginx over here, right? So let me go ahead with the host 2 with 32588. Okay, on the host 2, basically 32588. Now, there are different ways of also exposing services. So we have exposed it to the port number 32588. Because we have not given any port number, it has taken this random port number for us. Okay, so 32588, and if I access it, I'll be able to see welcome to Nginx. Okay, welcome to Nginx. Okay, so yes. Now I'm open to 5 minutes. Let's take a 5 minutes question answer session. So till this point, I believe now you have got it, right? So what is Kubernetes? What is orchestration? What is Kubernetes? Then what is how we can deploy the application? First, you have to deploy it, then you have to open it to the world. That means you have to add the services. And then there are components or the architecture with the Kubernetes. So if you have any questions with respect to that, do let me know. Or let me just take it one by one over here. By default, how many replicas are created? No, no replicas are created if you don't define the replicas. Okay, Lavanya is saying about Kubernetes versus Docker. Okay, Kubernetes versus Docker. So Docker is a container management tool. Docker is a container management tool. That means you can have a life cycle of the container managed by the Docker. That means you can create the images, you can install or create the containers, so on and so forth. Okay, and Kubernetes is about, let's say that you have multiple containers to manage. Docker cannot manage multiple containers. Docker cannot network between, let's say, a postpaid and prepaid services are there deployed on the two containers. Docker cannot manage that. Okay. Docker cannot auto heal. That means, let's say, one container is down. Okay, goes down. Docker cannot recreate that. Okay. There is no check by the Docker that this container is up and running or okay. Kubernetes is the one which will help you with the Docker with the auto healing, with the scaling. Docker cannot scale it. Okay, using like replica sets or something. Okay, they don't Docker don't have that feature. Kubernetes have that feature that if you define the replica set, it is going to. Okay. Yes. Okay, I'll explain that, Kiran sir. But before that, let's okay, sir. Microservices. Yeah, 1 minute. Microservices explanation. Creation related containers. Microservices. Okay, microservices is nothing but, let's say that you have a monolithic service. I have a simple diagram to it. Crew services, design pattern, services. No, not like this. Okay. So in short, you understand it. Microservices is like you have a monolithic service. Okay. You have monolithic service and you break them into the microservices. Okay. Let's say five microservices, monolithic services there. And now you are connecting this. Okay. One, two, three, four, five with each other. Okay. Now, because it's a microservice, that means a single service. Okay. Solution is one monolithic application. I divided into microservices. Now I created one container out of it, another container out of it, third container out of it, fourth, fifth. And now I'm going to network this container. And these five services, I'm going to deploy it on the Kubernetes. So this is what the microservices are there. And that's why containers are used in the microservices. Okay. Got it? Durga Prasad sir? Any good tools for the microservices? Uh, particularly in what terms? Okay, if you can define that, I'll be able to answer that. Okay, but Docker is the one. I think Containerid is the one, and Podman is the one. Okay, through which you can just create a very good container images and um, containers. Okay. Yes, Kiran sir, you please explain the steps after creating the namespace? Yeah. Okay, sure. I'll do that. Okay. But I need to go to board again. So I'll just take if I can answer some theoretical questions. Can a deployment be rolled back? Yes, deployment can be rolled back. Okay, as simple as that. You can just roll back or you can delete it. Okay, there are two options. You can just go ahead and you can delete that, and you can just roll back also. Okay. Um, Let me take some more. Docker software is on operating system, but when OS fails, what to do? Okay. Docker software is on operating system. That means it is completely dependent on the operating system. If OS fails, okay, that means the Docker is not going to work properly, and then you have to work on some other node. Okay, as simple as that. Docker Swarm and Kubernetes compared implementation wise. Docker Swarm is very good. Okay, I'll put it in. Again, I'm putting it, right? Docker Swarm is very good if number of services or microservices are less, if containers are less. Okay, management becomes very good. But when it comes to the scaling, when it comes to the high complexity microservices or solutioning, okay, Kubernetes is the right way to. Okay. Docker Swarm, if you are using Docker, pretty much compatible. And I simply suggest to the startups also I suggest them that please go ahead with Docker Swarm first. Okay, if you don't have something big to offer, go ahead with Docker Swarm. Kubernetes is for a large scale applications, okay, where you are divided, let's say 10, 20 microservices and then you are serving it. Okay. Can multiple containers from the different region be joined in the Kubernetes network? Can a multiple containers from the different regions? Now, particularly with the regions, if I say, I'm not sure, but yes, you can have multiple containers inside one pod. Okay, and that pod, okay, can be connected to another pods also in a different region. They can interact with each other based on the API server. So everything, every request, every communication is going to happen with that API server. Okay. So this way you can work, right? Yes. And if you add that node in the Kubernetes cluster, yes, even though you don't require API, you can directly then communicate with it. Pretty simple, right? Next question is, can you please share your GitHub ID so that we can take some notes regarding the Kubernetes? Okay. Standalone machine. Okay, I'm not sure that whether I'll be able to do it. But yeah, I'll give something through which you'll be able to do it step by step. Okay, don't worry about that. Can I multiple containers from the different regions? Okay, GitHub ID, I'll just going to put it. So it is cloud dev user. Okay, and this is basically Kubernetes demo. Okay, this is the repository. Okay, you can just follow this repository. There are lots and lots of things with respect to the examples and okay, which you will be able to do it. Okay. So yeah, so we'll take another 10-15 minutes to understand few more features, and then we'll go ahead again with the question answer sessions. Okay, I know completely understand there are a lot of things with the Kubernetes, but yes, let me try to move ahead with the next one. Okay, now there is something called as label and selector. Okay, Kiran sir, Kiran Deshpande sir, I'll just come back to you. Okay, I understand that you want to understand after namespace what happens, that how deployment happens. But yeah, another 10 minutes, I'm going to push it for my PPTs. Okay, and then we will cover about the proper again with the deployment topics. Okay, we'll also understand about the replicas and all. Okay. So labels and selectors in Kubernetes. Okay. So labels and selectors are basically a key value pairs. Okay.
Yeah.
In short, you understand it in this way. Let's say that there is a factory of clothes. Okay. So there are number of t-shirts which are created. Okay. Hundreds t-shirts which are created, and then we are putting the labels of different companies. Okay. Let's say one is Cotton King, one is XYZ, one is ABC. So 10 t-shirt for ABC label, 10 t-shirt for let's say XYZ t-shirts. So in the same way, okay, when you deploy the application, what you do is you create a label for that application, or you deploy the application with a particular label. So that is what the label is. So it is basically a label is a key value pair through which the application is recognized. Oh, okay. And then let's say you want to update that application. So how you are going to update it? Based on the selector. So when you say select application with this XYZ label and get updated. So accordingly, it is going to have that application updated using select method. Okay. For example, selector is app equal to nginx matches all the pods that have label app equal to nginx. So while deploying, what we do is we deploy with the label, and while updating, while deleting or anything, what we do is we select it using a particular label. Okay. So now there are two types of labels. No, sorry, two types of selectors. Okay. With respect to that, you have equity base, that means app equal to nginx, and set base. Set means there are two or more. Okay, there are two or more labels attached to a particular thing. Let's say database container is there. So database, okay, for Eagle application. So DB equal to Eagle DB, and database type equal to Postgres, something like that. Okay. So accordingly, you can have selector app in Nginx and PHP that matches all the pods. So similarly, we have selectors. Okay, so labels and selectors are there. Okay, creating a pod and deployment using the YAML. So as simple as that, right? So as I told you, pod is the smallest unit. So what is there inside the pod? So it starts with the API version. Okay, so we have an API server for which we have to give the API version. Which API version you want to use it? So in the API version, in the API server, you have different API versions, V1, V2, okay, V1 apps, something like that. So there are different API versions serving different types of request. Okay, kind. Okay, what kind of things you have to create? You want to create a pod, you want to create a deployment, you want to create a service, you want to create a service account, or what exactly? So that is we are going to mention it over here. Then given that metadata means information about that, and then the specification that which container needs to be deployed. So this is the definition of pod, which you can go ahead and you can deploy it on your Kubernetes. Okay. Now this is a single pod. That means a single container is deployed. But when it comes to the deployment, okay, deployment itself has all those definition of the pod, plus we have something called as replicas. We have something called as replicas. So here I have defined replicas as three. That means three instances of that application will be deployed. Okay. And then we don't define in the pod way, but we define in the template way. So what we are going to define it, okay, anything with respect to the deployment is created will follow this template. Template is app label app equal to nginx is there. Specification I'm going to give them as containers. Okay. I've given you that GitHub repository. Everything is explained on that. There are good examples to it. You can just go ahead and you can run it on that. Okay, based on your time. Okay, so that is what the difference between a pod. Pod is single deployment, okay, or single container or single pod you are deploying it. Okay, it has no uh, any to and fro. But with respect to the deployment, okay, it's a proper set of applications or a set of single application which are going to deploy, which are going to deploy it. Okay, by defining the replicas. Okay, services. So as I told you, right? So once you do the deployment, your deployment is done. But now you want to expose it. So how you are going to expose it? There is a component called service. So what is services in Kubernetes? It's a resource which provides a load balancing within the Kubernetes cluster, network connectivity and load balancing within the container. Or I would say it is a logical name given to your deployment through which it can be it can be accessed from the outside world. Okay, so there are three types of services are there: cluster IP, node port, and load balancer. Okay, external name is there, but cluster IP, node port, and load balancers are the major one. So cluster IP means you don't want to expose your application outside the cluster. So what you do is you give the cluster IP, and that services or that application will reside inside the application. That can communicate inside the cluster, not outside the cluster. Node port. Node ports exposes the application or the pod to the outside world using a particular port on the node. Okay, so all the nodes, okay, so each node IP address with a specific port can access that application. Okay, third one is a load balancer. Pretty simple, right? So you define external load balancers. You create a load balancer. You attach it to your cluster, and then you define the name of the service with that load balancer service name. Okay, and then external name is basically you can map it with the some external DNS name. Okay, with the A type or C types of records. So this is what the service is. Okay, I completely understand. Yes. So the last one with respect to the replica sets and ruling updates. Okay. So somebody was saying about, okay, can we scale it up and scale down? Can we have rollback also? Yes, this is what the solution is, right? So you can define the replica sets. Okay. What basically replica sets is, it's ensure specific number of pods replicas are running at all the times. And rolling update means rolling updates, it is going to update your pods. Let's say that there are three pods which are existing, three pods are there. Now you want to update it with the new version. So what rolling update will do is it is going to put one pod down, update it, create another pod, then it is going to put another pod down, update it and create another pod, then it is going to put the third pod down and it is going to create the third pod. That means it is going to have a rolling update. One, two, three, like this. One, two, three. Getting it? That is what the rolling update is. Okay. So now we will take quick examples of it. That you have your replica sets where replicas are defined over here. But in the rolling updates, you have your image. Okay. Image definition updated in Unix version. That means this image. Let's say you are running 1.14.0 and now you want to update it to 1.19.10. So you are going to put 1.19.10. So it is going to do it one by one. One, two, three, like this. So one goes down, two are still up and running. Okay. Then one goes up, second goes down, then third goes up, the, the second goes up, third goes down, and then third goes up like this. Okay. So there is a zero downtime. Okay, when you do the rolling updates, right? So in short, that is what the Kubernetes is. This is just a tip of iceberg what I've given to you, but for sure I'll tell you that there are lots and lots of things, okay, which can be added to it. Okay, so Kiran sir, quickly to answer your question, and then I'll be open to the question answers in that. Okay. So now let me just clear it out. So we have a namespace, so kubectl get namespace, right? Kubectl. So this is my demo namespace is there. Okay. So namespace means you can define the resources, CPU, memory, and disk to a particular namespace. Okay. What next we have done is um, we have we created a deployment. That means we deployed an Nginx app with the name Nginx app. I have given the image as Nginx. Okay, so latest Nginx image will be used. That is the Docker image, and replica is equal to 2. That means two instances of deployment will be created. So if I say two are here, so it is saying failed to create. That means it is already created. If I say three replicas, it is going to modify it. Okay. But we need to say kubectl update the deployment like this. We have to update the deployment, but let me not do that. Okay. Let me just quickly clear this considering the time constraint, and let me delete it, the deployment, to show you again. Okay. So three replicas now. Okay. So I'm just going to create a deployment and kubectl get deployment in Unix -app. So here, sorry, my bad. Here I have three replicas of it. And then I'm going to expose this. Okay. Already I have exposed it. Okay. The Nginx deployment is already exposed it. Okay. So to 80. Okay. So what I'm going to expose it with the node port type. That means I'm going to choose a node port for port 80. So port 80 is the Nginx port, which will be mapped with the node port given by the Kubernetes for the particular deployment. And using this node port, we'll be able to do that. Now, this is a different arrangement over here through which you can just go ahead. You can give that port like this, 328, and then click on access. So here you will be able to see the Nginx web application. So, sorry. So that is about it. So if you have any questions, do let me know. OpenShift is also, yes, OpenShift is also good.
Now mic is open to all. So if you have any questions, ask.
So I'm open to questions now. If you have any questions, do let me know. I completely understand. Okay, the topic is very vast. Okay, and few of the things maybe I would have missed out. Okay, but I tried my best to put all the things come together and at least give you the some knowledge with respect to the Kubernetes. Right? Deploying the host and containers. Okay. Let me just take these few things. Uh, the replica set is different from deployment. Yes, replica set is different from deployment. Yeah. So it is going to define the replica set is for defining how many replicas help. It is not going to create the pods. Deployment is the one which is going to create the pods. Okay. And Replica set is a subset of deployment. Okay. Just like for the tea, milk is important. But yes, you can have a tea without a milk also. Okay. So replica set is the same. That in the deployment, you put the replica set and accordingly Kubernetes will respond to you. Okay. So there is a difference between deployment the host and containers. Deploying the application on the host and containers. Yes, there is. So application is when you go ahead with the container, application is packed inside it. And then you take this container, you deploy it somewhere. But when it is a host, you have to first install all the OS, and then you have to install all the required dependencies, and then you have to install on the top of it the application. And then you will be able to run that application. The host will be dedicated to it. But containers, you install it, run it, delete it, again create it, and that's it. That's how it is. So I think it is 2:30, but with the permission, if I can explain it for one more minute, Balaji sir.
Yes,
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 sir.
sir.
Yeah. Okay. Um, yes. So how about efficiency when we use many microservices into many parts and use it in the container? So Swarm, I really don't recommend it when it is like 20-25 services, microservices or more than that. Okay. You go ahead with the Kubernetes, but if it is 5 to 10 microservices are there and you want to have maybe in the different regions also, Docker Swarm is really. Can you orchestrate VM with the Kubernetes? So VM is completely different concept. VM is based on hardware virtualization. Okay. Kubernetes is based on the OS virtualization. A container is basically the OS virtualization. So both are different concepts. So you cannot have a VM orchestration with the Kubernetes. Kubernetes is dedicated to the what do you say to the containers only. Okay, so it is like you have a golf uh, and the cricket. So cricket is completely different genre, and golf is, even though they are played with the ball and stick, but both are different games. Okay. Right. So I think I'll give overview of today's session in 3 minutes. Okay. And can we run KS8 on low config system? Yes, there are tools like Kind. Okay, you can just go ahead and you can just Kind, using which you can run Kubernetes on containers. Okay, on Docker. Okay, Kind is a tool. Minikube, yeah, Minikube is good, but then Kind is there, Customize is there, Customize is also there. Okay, so simply you can just go ahead with these tools. Pretty simple to have practice and all, right? Guidance on certification. Oh, there are a lot of questions. Okay, probably tomorrow I'll be there with the helm also, so I'll be able to answer these questions also. Okay, certifications also, I'll just keep that. Okay, so yeah, that is pretty much. I think if you have any questions, you follow it or you can share it with the dean sir or with the ma'am. Okay, and they can mail me. I'll try to respond it through the email. Will that work? Yeah. So, okay. So that is pretty much from my side. Yeah. So you can email your questions to madam and sir. Okay. They'll share it with me and respond to all the questions. Don't worry about that. Okay. Thanks all then.
Okay, sir. Okay. Thank you, sir.
Yep.
Thank you for your
Thank you.
informative and engaging session. And we appreciate at the time you share your knowledge with us, sir. Thank you.
Yep. Thank you. Thank you all then.
Thank you.
Have a good
Thank
day.
you, sir. Thank you so much, sir. Thanks
Yep.
for your
Thank
time.
you. Really appreciate you this opportunity to share my knowledge. Okay. I'll be more happy to share such sessions or having such sessions in the future
Thank,
also.
thank you so much, sir.
Yep.
Welcome, sir.
Thank you. Yep. Bye bye. Good night.
Without any delay, I request Dr. N. Balaji, sir, introduce our next speaker, Dr. N. Milton Ganesh, sir. Sir, please.
Wait a minute, ma'am. Yes. It's my great honor and privilege to welcome Dr. S. Milton Ganesh. He is an experienced academic and researcher in computer science and engineering with a PhD in information and communication engineering from Anna University. He is currently the assistant professor and head in charge of the IT department at the University College of Engineering, Dindivanam. His expertise spans cloud security, network security, and vehicle radar networks with over 2 decades of experience. He has guided numerous research projects, published widely, and contributed to software development. He has also delivered guest lectures, attended faculty programs, and held administrative roles. I welcome you, sir. I kindly request you to take over the session, sir.
Balaji sir, good evening.
Good evening, sir.
Yeah, can you hear me and can
Welcome
you
you, sir.
see the presentation, sir?
Yes, sir. Yes, sir.
Thank you very much, sir.
You can start. Yes, sir. You can
Yeah.
start, sir.
Yes, sir. First of all, I would like to thank Balaji sir and Ondal madam for painstakingly arranging this Atal FTP. I know that organizing a physical FTP itself is very a daunting task, but a person like Balaji sir and Ondal madam, I know you have you should have put in, and you would have put in so much of hard work. For I think you have been arranging this work for more than 1.5 months and arranging the guests and scheduling the sessions. So at this juncture, with more than 150 participants, I think this session is going very well. And also, I feel very much elated and happy to be part of this wonderful FDP. As a resource person, I would like to touch upon the topics related to Kubernetes, storage, and configurations. So before delving deep into the theoretical concepts of Kubernetes storage and configurations, I kindly request the audience to permit me to discuss about the basics of software development lifecycle and the evolution of containers with its support for DevOps and the need for Kubernetes, and finally the importance of storage and its configuration in Kubernetes. As a student, everyone who has learned about computer science would have come to know about software engineering. So when we talk about software engineering, people think that software engineering is all about the people who code alone. But behind the scenes, once the software is created and it is moved to the server where it is available to the clients, that kind of server, we call it as the environment called production environment. But people, the layman, or the students who are studying engineering or bachelor's degree in other disciplines, they are not aware of the work done by the people who maintain the software after it has been deployed to production. The real issue nowadays, people and that means the end users and the clients, the business service providers themselves, are facing is with the maintenance of production environment. Nowadays, there are so many software tools to develop code, but it has become very, very tough to maintain the software in the production environment. Here, the software development lifecycle, actually in our curriculum, we would have learned about software engineering. It's a kind of workflow which consists of requirements gathering by going directly to the client environment, sitting with the client, understanding the needs of the client, understanding the business needs of the client, and noting down everything. Finally, we do a software requirement specification. Then we go for designing it. There would be a experienced coding team who would have been doing the designing work. Basically, they will do designing work. In 1980s and 1990s, they started doing object-oriented analysis and design kind of thing. After that, they would go for development. Maybe it is top-down approach or bottom-up approach, as we see in object-oriented programming. So after the development, the code is deployed. So the code is deployed and it would be maintained by the people in the production. What am I talking to you is in 1980s and 1990s, where the concept of cloud was not available, where the concept of on-premises, very big kind of storage servers were not available. That means it was available only with very big software companies. After the software is moved to the production, it would be managed or it would be supported for any errors. Actually, support would be for 24 hours upon base support. Actually, this thing is what is called as the phases of software engineering. Here, the software engineering can be done through different models, like waterfall model, where requirements gathering would be stopped at a particular stage. After then, software developers did go for developing the design. Once the design was over, the phase of coding started. After that, testing would be started. Finally, the code would be released to the client. Different kinds of support would be provided. One kind of support is on-site support. Another kind of support is offshore support through on-calls, phone calls, and raising the tickets. This was with software engineering. Nowadays, there has become a different kind of workflow which the software industry itself is moving to. Nowadays, you can see that a student who graduates engineering or any other computer science course is not expected only to develop code. A student who has passed the degree and he is looking for a software engineering job or a coding job, he should have knowledge in front-end code development. It includes UI UX design if it is a web-based application. He also has to code, maybe using pure HTML code or React code or React code or Angular code if we are talking about a single page web application. He should also know how to write APIs where the business logic themselves are being run in the backend. The actual business is run in the business logic servers. It is in the middleware or middle layer. The business usually the clients access only front end. Now a software engineer has to develop front end, and also he should know about developing APIs in the middle layer. Also, the same HTML developer or React JS developer or Angular front-end UI UX designer should also need to aware of the back-end database servers also. This is what we call as full stack web development, full stack Java development, full stack .NET framework development. In .NET framework also we have got Windows-based applications, and also we have got web-based applications. Nowadays, a software graduate who graduates from the college needs to be aware of all these three things: front end, managing and writing APIs, and you should also have the knowledge of database. This is one part. This is one part only. Apart from this, in the next 2 to 3 years, it is not about if, it is only about when. The topic, which is what we're discussing now, is about DevOps. Developing, moving, and managing the entire software application in the cloud. Actually, what we are discussing is all about not SaaS, software SaaS. It's all about PaaS. Software as a service means the whole application itself would be provided by the cloud service providers. For example, Gmail, we need not do anything. We just pay the fees through our international debit card. We get different number of emails for our office. If we want any other service like the storage space, increase in storage space or decrease in storage space, if we want our domain name, if we want different kinds of security or for different kinds of protocol, we can define it accordingly. If we pay, we get the service. This is SaaS. But what this FDP is about, DevOps is not about SaaS. It is about PaaS. PaaS means platform as a service. Platform as a service means the application is not provided from the cloud storage service provider. The application is actually developed in the on-premises. On-premises means when you are working in a TCS office, your project manager, your team leader, your group leader will go on site for some time, and he will sit in on calls in the offshore at some time. He will get the business requirements. Accordingly, he will make a plan for when to release which part of the software. This is sometimes when I was working in a project, they call it as time box. They would get the requirements once every month. They would move a small part of software coding to production. So time box 1 means a small part of software would be moved to production. In the time box 2, maybe it is next month or 1.5 months or 3 months, depending on the effort. It is planned already. So next part would be moved to production. This is how it goes. This is what is called as PaaS. Now, here I am talking to you about software development lifecycle. It is not about software engineering model. It is a software development lifecycle. In the next 3 to 4 years or next 2 years, graduates who are passing your degree should have knowledge about cloud native operations. In cloud native application development, we have different kinds of technologies for business workflow, like DevOps, like security ops, like platform ops, like performance ops. Different ops are available. DevOps is something which integrates software development and also the maintenance of the application in the production system. Usually nowadays the production servers are rarely offshore. Offshore means in the TCS office or Infosys office. Mostly the production environment is only with the cloud service provider. If the project is a very big project, like maintaining the other data, like providing DigiLocker facility, now the government, even you know that every business and the government is moving each and every application
Dear participants, wait for a few minutes. Sorry for your inconvenience. We have an important update for you all. And I request all the participants to give the Atal a registered mail ID to join the session as well as fill the feedback form also. So kindly rename your GMeet ID with your college name and your name. You can use the short form of your college name also. So if you attend both session alone, you will be marked as present. So both the GMeet and feedback link address will be considered. Attend the both sessions. 80% of attendance is mandatory for a certificate. So kindly attend both sessions.
Dear participants, kindly wait for some time. Our resource person, now he is in Oman, Muscat. So that I think he is having network issues. So kindly wait for some time. Thank you. University, வேணும் பண்றோம்.
we also have another role 2, which has been granted privilege C. In addition to that, role 1 is granted to role 2, and finally role 2 is granted to user 1.
So hi all, Ravi here. So if you have any questions, I've just joined again. Okay. If you have any question, you can just put that in the chat. Okay. And I'll be able to answer that. Okay. Is it working now? Everyone is able to hear?
Yes, sir.
Yep,
You're
sure.
audible.
Yep, sure. Thank you. So probably we'll take a quick quiz with respect to the Kubernetes and storage. Okay, just to have some. Let me just put few questions. Okay, so this will be you can just follow a rapid fire round over here. Okay, let me put the question, and you are going to give the answer. Okay, so the first question goes like this: what is Kubernetes? A container runtime, a container orchestration platform, programming language, or database management tool? B. Okay, right. Okay, this is pretty simple question. Okay. Um. Okay. So we go a bit. Uh. Yes. Everyone know that. Okay. Now next question is this: which component in the Kubernetes is responsible for managing the pods? Managing the pods. Kubelet, kubeproxy, etcd, container D. B. Okay. A. So those who are given A is the correct answer. Okay. So it is a kubelet. Okay. The answer A is correct. Right. Next question goes like this. I'm not sure if you are. Okay. So this is what we have also covered it. But let's see how many of you remember that. Which command is used to create the namespace? Okay, so kubectl is the same. Create is also correct for the namespace. B. That's correct answer, right? Um. Okay, so I'm not sure if you know about this. Okay. Let me do that again. Right. So this is again one more question which is coming to yes B. Okay. The next question goes like this. What is the function of Kubernetes deployment? C. Right. So C is the correct answer to manage the lifecycle pods and ensure the desired number of replicas. Right. We have done that. Right. Okay. On the top of it again, the question to it is this. That is correct. Now, next question we are going to is what does Kubernetes replica set do? Manages pod scheduling, ensure number of specific pod replicas. B. Okay, good. Okay, let me put some hard questions to you. Let me put some right. Now, this is something you you learned about it, but I'm not sure if you know about this. Which is the default type of Kubernetes service? Cluster IP, node port, load balancer, or external link? Okay, a logical question. Okay, all are Kubernetes services only, but which one is the default one? DC, DC. External load balancer by default. DCA. So by default it is cluster IP. By default it is cluster IP. That is A is the answer. Okay. So there is no load balancer by default. Load balancer you have to create it. See, logically you have to understand. Node port you have to define it. Okay. Load balancer you have to create it. DNS, that is external name, that is DNS routing, you have to do it. What is there as a permanent part? That is cluster IP. So by default, cluster IP will be the default service. Okay. What is? I'm not sure to know about this. What is the default? If you are now having a default storage class in Kubernetes, I'm not sure if you know about it. But let me just put presentation. I think ma'am and sir, Dean sir will be able to share it with you at the end of the session. Okay. So what is the default storage class? A. What is A? What is A over here? No, the answer is B. The answer is B. So standard is a default storage class. So it is not default, but it is a standard one. Okay. Let me just put something interesting. Sorry. So let's go ahead and let's understand this. Okay. The next question is this. What is storage class in Kubernetes? What is storage class? A class considering network policies, a class used to define the storage policies, class used for pod scheduling, or class used for service discovery. All right. So you can remember it in a very simple way, right? It defines the storage policies. Okay. Just like we have 1 star, 2 star, 3 star, 5 star hotels, right? Accordingly, we'll have a different class for that hotels. In the same way, we have a storage classes. Okay. So what we do in the storage class, we define the storage policies. Okay. So when I'm saying when I'm defining storage policies, what kind of files or folders or how I'm going to store that, that is what I'm going to define in the storage class. Okay. So it is basically a class used to define, answer is B. Class used to define storage policies. Right. Hmm. Let me just put another question. This is again a concept in Kubernetes. Okay, might be covered, might not be covered. I'm not sure. But what is daemon set in Kubernetes? Okay, so remember that daemon set is nothing but it is a daemon. So do you see the daemon? No, you don't see the daemon, right? So basically, it is a set of pod that ensure one pod runs in the background in each node. Now see, each node they are talking, right? One pod running in each node. Okay, one pod running in each node. That means every node will have that pod running. That's why it is called as daemon, running in the background. So we don't see the daemon. Daemon is always there, but we don't see. That means a pod, daemon set is a pod which is running in the background, like a system process, of course. Okay. Which command is used to scale the deployment in Kubernetes? Which command? Yeah, daemon. Yes. I'm not sure if you have heard about zombie processes also. So there is something called a zombie process in Linux. If you're interested, you can learn about it. Okay. So which command you use to scale the deployment in Kubernetes? Scale the deployment, resize the deployment, increase the deployment, expand the deployment. Yeah, of course, it's a A. So it is to scale the deployment. All right. Okay. Hmm. What is Kubernetes ingress? Ingress. What is Kubernetes ingress? A type of pod, a set of rules that expose services outside the cluster, a type of config map, or an interrupt policy. What is ingress? Hmm. So basically, the ingress and outgress are the two, or outgress are there. See, basically, when you talk about ingress and outgress, generally those are related to the routing. Okay. Now I have a routing in terms of two ways. Okay. First, in terms of the port. Second, in terms of my services. Okay. So what I need to do is, let's say that you went to someone's home. Okay. But then you need okay, you went to a particular your friend's home for the first time. So you need someone to navigate you to a particular location. Let's say that you want to go to kitchen, you have to go to hall, you have to go to gallery. Okay. So you need that friend who know everything about it. Right. So that is how we say ingress. So somebody is coming inside your home. So how he or she will be routed? That is ingress. Okay. But let's say that you're going to go to some beach location or to some mountain, okay, from your home to outside. Okay, so there will be some guide, okay, who will be telling you that how to go. That is outgrace. That is called as outgrace. So what is coming inside is ingress. What is going outside is outgrace. Ingress with respect to Kubernetes is a pod which is defined, okay, which is nothing but a nginx, and in the nginx we define the rule that if the request is coming to our Kubernetes, how and where it will be navigated. So you can define that. Let's say if request is coming from for a ABC application, okay, route it to the node port 32440. If request is coming for this XYZ application, route it to the load balancer of XYZ application and it will get routed. Okay, accordingly, right? So answer is B. It is about the rules. What is the purpose of Kubernetes job? Okay, so these are basically the controllers. If you want to learn more about it, no, you can learn more about it with the controllers also. Okay, these are basically about the Kubernetes controllers. Kubernetes job. Okay, as simple as that. Okay, if you have heard about the cron job, in Kubernetes, it is the same thing. Yes, but to manage the configuration data, no, that is wrong. B is the answer to it. Okay, to ensure the execution of the task to completion. So it is as simple as that. Your cron job is there. Okay, so you execute it and you close that. Okay, so pod will be up and running. That will get executed. The task will be executed, and then pod will die or it will go down. Okay, for example, let's say you have a payroll running on every 30th. Okay, every 30th of the month. So every 30th of the month, this job will be created in the Kubernetes. That means a pod will be created in Kubernetes. Inside that pod, this application is there, which is going to process your payroll. The application will be executing your payroll, and then the pod will go down. As simple as that. So such kind of pods where a task is executed, okay, that is called as job in Kubernetes. So those are called as Kubernetes job. This is one of the controllers. Okay. Now, maybe I'll going to give you the last question to you. Which command is going to give it to the persistent volume? Okay, which command is used to delete the persistent volume? Remove, delete, get, create. It's delete. Okay, so probably, yeah. So here onwards, I think the other person will take it. Okay, uh, with the further updates. Okay, so thanks all then. We'll continue our session tomorrow. Thank you. Have a good day. Bye bye.
Thank you, sir.
Yeah.
Itu dah killer. Dear participants, I apologize to everyone. Due to technical problem, our resource person, Dr. Milton Ganeshan, is not taking the session. I think he is having network issue. Right now, he is in Muscat. He is attending today conference. So that I will arrange this session 4 in upcoming days. So I will post in the group. So I apologize to everyone. We'll take the session on upcoming days. Okay. I will share the details tomorrow or day after tomorrow. I will share the details to you. Okay. Thank you for attending, all the participants. Ma'am,
Dear participants, day 1 and day 2 feedback links shared in the chat box. Kindly check out and kindly fill out the forms immediately. Thank you all. Looking forward to welcome you all tomorrow with the same enthusiasm. Thank you all. Abhirami ma'am, kindly share the feedback link.
Thank you for all the participants. Thanks for your support. Andal ma'am, Pavitra ma'am.
Sir,
Next என்ன ப்ரொசீட் பண்ணிடுங்க.
okay, sir. Thank you for all participants. Upcoming sessions, we will update you tomorrow. Thank you all. Now you can leave the session.
Sir, the session is over. I request all the participants to kindly leave the meeting. Tomorrow we have to share the schedule in the WhatsApp group.